started on our second module. So what we're going to be looking at here in this next part is the port and the service discovery. And I have my contact information copied here on the Word document I'm going to follow. Basically, if you want to get video posting announcements for the YouTube channel, or if you want to get announcements for updates on Matilda Day releases, that's the Twitter I use for those. Don't use it for a whole lot else, so it's probably not much good for entertainment value, but I'll put the links to these presentations and other presentations we do for the ISSA monthly meetings out to that Twitter. So Adrian had talked about the some of the protocols that were in use, the TCP and UDP, and we can control those protocols more closely depending on the situation. So if you know you want to scan for just TCP services or just UDP, or in particular if you want to search certain ports or port ranges, you can control those to greatly increase the scan timing, especially on UDP. If you recall when Adrian was speaking earlier, he mentioned that the UDPs don't get responses when the port is closed in most cases, and Nmap will wait for about a second for each of those responses to time out. Doesn't sound like a lot, but if you do that over thousands of ports, it can cause the scans to take a very long time. Remember that those numbers are multiplied by the number of machines that you're scanning on the network. So it can take a very long time to scan if you don't narrow the number of ports down. So,
what's up, Adrian?
So to look at some of this traffic a little bit closer, and you can do this in your computer as well, we're going to use TCP dump. You can also use Wireshark alternatively if you'd like. They're both included in Kali. TCP dump uses this basic command here, assuming that your interface is ETH1. You can do an ifconfig to figure out which interface is connected to which network to make sure that you're dumping the traffic for the correct network card. If you don't pass the -I option, the TCP dump, it's going to try to collect on all the interfaces. It works fine, but it makes it virtually impossible to see what's going on. There'd be too much traffic. And the -NN option just keeps the TCP dump from trying to resolve the host names, which in itself is not necessarily that big a deal, but it also keeps it from trying to show the friendly name of the port. So instead of saying 80, it would say HTTP, and that actually makes it harder to read, in my opinion. But either way, so if you want to fire up TCP dump, you can. And we're going to be following this URL reference here. So on the send scan that we saw earlier, I'm going to pick a particular port that's open, and I'm using Metasploitable 2 as a target. If you have a Metasploitable 2 virtual machine running, you can follow along. There's also a Metasploitable 2 running in the target network as well. Of course, you'll have to figure out which box it is. You can use
eventually there'll be one.
You can use the -O option to try to figure out which one's which. All right, so let's go ahead and clear out the screen over here. Now, in my TCP dump, I'm using the host filter, and so you put host and then the name of the IP address that you want to only look at packets for. In this case, you can do it either for your Kali instance or for your target, because either one is going to be either the source or the destination, so that would work just fine. You don't have to put both. In this case, just to show the full syntax, I've got both host of the target and the host of Kali to filter out. The ampersand is and that's the way to connect them together. You can do ORs as well. Right, so we'll dump this traffic out and do we use the -SS option to trap it into doing a send scan. Of course, we're running as root, so it would do that anyway. Okay. Has to get warmed up, apparently. Okay. So we can see that on port 3306, we're looking for a MySQL server that we sent out, we being 102, sent out a send packet, and that's shown over here in the flags. So the S is send, and then we receive back the send ACK. The dot is ACK, so S dot is send ACK. And then we sent back a reset immediately. So you can tell this is a send scan and not a connect scan because we didn't send back the requisite ACK to do the full connect. All right. Then we can change that to the full connection option. If I can remember what it is, since I never do these. Let's see, I think it's S. I have to look it up. Sorry, I never. T, thanks. I've never used that option before, so it really is not very practical for daily use, and Nmap will automatically use it when it's trying to do the service scans. But just for demos, it's useful. Okay, so again, we sent it out on 3306. We sent out the send, and the send ACK came back. But this time, notice we sent an ACK in return, and then we sent the reset ACK to tear down the connection. So the basic difference between those two scans. So when would you use one or the other? Well, you really wouldn't use the full connect scan unless you had to. It is used for service version detection, but anytime you use the -SV option, we'll see later, Nmap is smart enough to understand it has to make a full connection, so it's going to go ahead and upgrade to the full connect automatically. All right, we'll take a look at some of these other options. So if we only want to do scanning on the UDP protocol, we can use the SU. The good thing about this protocol is that there are going to be services on most machines running with UDP, and if you just do a regular scan without specifying the UDP option, you're never going to notice those services. Because with the -SS, the default option, implicitly that's a TCP scan. But some of the services running on UDP are pretty useful. There's a DNS can be running on UDP by default. It can also use TCP as well. And then the SNMP service on 161 is a great find if you can get it. A lot of times the SNMP service will give you things like the usernames on Windows servers. It can give you what processes are running, what the netstat content looks like, in other words, what machines that machine is connecting to, and so forth. So those are a couple of UDPs to look for. Also, if there's Windows shares running, a lot of times you'll see a 137 on UDP. But you would typically see that also in the TCP side of the house with 445 and 137, 139. So you may be able to pick up the Windows shares either way. You'd be surprised how many times those Windows shares are just wide open.
They're open, I think.
And they're open by default, and by default, NTFS permissions don't restrict access to the shares. And they're actually kind of hard to set up correctly in a secure way. You have to coordinate your share permissions with your NTFS permissions, and it's kind of a pain. And anytime anything like that is a little bit difficult, chances are it's going to default open. So definitely don't want to ignore UDPs. But it is slow for the reasons that Adrian mentioned. Now there are other scan options that tweak the flags, the windows, and the packet contents. And what they're used for is under certain circumstances, you can actually get packets to go through different perhaps firewalls or other things that might be blocking and still detect the port status, or at least get a good guess on if the port might be open. And those are respectively the null fin and the Christmas tree scan. And then also I grouped the Maimon scan into this group as well. They technically are sending packets that are not actually legitimate in most cases. For example, the Xmas scan has all of the flags, so it's going to be a send, a put, an ACK, and an urge, and every one of those flags is all set to a 1. That packet makes no sense at all, but there are computers that will respond to that even when they won't respond to a normal packet. The bad thing about using these techniques is that they only work on certain machines. So you very well may have a service that's running, but you still can't detect it because the machine is not one of the ones that this stuff works on. However, you can do ACK scans where you're only sending that ACK that we looked at a second ago. There's different kinds of firewalls. There's stateful firewalls, and there's packet filters, and then there's proxies. The stateful firewall is kind of the standard firewall you would have at home if you just went out and bought a router from your favorite electronics store and you plug it in. It's probably going to be a stateful firewall. That's typically what you'll see in most any modern equipment. But there are some specialty firewalls that are designed for speed, and there's also some older firewalls that were just packet filters. The difference is that stateful firewalls have the ability to keep track of the state of different packets and relate them to one another into sessions. So, for example, if we were to send a ACK packet out, a stateful firewall would know that's out of sequence. And let's see, we can do, let's see, that's the SA. Let's make sure I got my flags correct. So we'll send an ACK. All right, and there we go. We have an ACK packet coming from our host over to 3306, the MySQL server. And we actually did get a response back, so it worked. We can tell that port is listening and responding. They sent back a reset, and that's correct because we violated the protocol. We never sent the SYN in the first place, waited for the SYN ACK to come back, and then respond with the ACK. We sent the ACK out of order, and so the port responded with the reset, which basically means you didn't follow the protocol, and I'm not going to be able to work with you. But it doesn't matter that they sent us back a message that basically says we're on the naughty list. The fact that they responded at all means that the port is responding. So we got what we were looking for. And you'll notice over here that after the ACK scan on that port, you can see that Nmap used that information and shows that 3306 is at least unfiltered. So it's not being blocked by a packet filter or a stateful firewall. Now the stateful firewalls can remember previous packets that have already occurred. So if a stateful firewall saw an ACK come through, it would recognize that it doesn't have a corresponding SYN and SYN-ACK in its memory that match up to the current ACK. And so those types of firewalls would simply drop the ACK, and the target machine would never see the traffic.
Fuck doesn't have to.
Now, you are allowed to set the scan flags however you want. So you can pick any of the 8 flags and turn them on or off in any sequence you choose and send those and see what happens. So that's actually a pretty interesting experiment you can do. You can put Nmap into a loop that works through the flags one at a time and then starts to work on the combinations just to see what happens at the receiving end. So, and there is one other scan option that is technically it's not a TCP scan. It's just a protocol scan. So if you recall back in the earlier slides, there's a spot in the IP packet that allows you to say which protocol is being carried by the IP packet. So if you see, I think it's a 6, that is TCP. So if you saw a 6 in the IP field, you would know that it's carrying a TCP packet. And then there's other numbers for other protocols. UDP might be 17 or something like that. You can check out the IP flag. The SO actually works, goes through those numbers, because sometimes you can get responses from the targets that'll at least tell you what kind of packets they support, and that would tell you what kind of scans you might try to do. So we'll do a SO. since it's not a scan against ports, it's not, in other words, it's not a TCP or a UDP scan, it doesn't really make as much sense to specify the port in that case. Okay, so we see, well, a whole lot of IP protocols getting tested. So it's not even actually going through them in order, it's just, but it is running through the list of possible protocols.
Is that IP address local to your VM network or something?
Yes, the way this is set up is, let's see if I have VirtualBox running. Yes. So I have a Metasploitable 2 VirtualBox, and I also have Kali, and they're both running. And they're going to have IP addresses of 192.168.56 dot something starting at 101. That's the, by default, that's how VirtualBox allocates the host-only network IP addresses. The host-only network is just a virtual network that's running on this machine. It's not a real network in that it's just packets are being transferred back and forth within this one host. However, the host operating system is also on the host-only network. So even though no one on a regular network can see the host-only traffic, the host operating system itself can participate and see the traffic. And I've got Metasploitable running just as a target. It's actually Metasploitable 2. And that's what we're scanning against over here. All right, so we run through lots and lots of protocols there. It might take it a while to finish, so we can kill that one.
If you're scanning something and it hasn't started showing stuff on the screen or whatever to give you the output or whatever on a specific IP address, and you quit out of it, is there a way to quit out of it and still be able to see the information that it has gathered to that point?
Oh, dump what it had at that point? Not if it hasn't printed anything, but if you're going through a scan, typically you're going to be scanning a range, and maybe you made it through 10 hosts or something like that, and then you cancel the scan. So if you were outputting the information using one of the -O options, like -OA or -OG, then it's saving what it had up to that point out to the file. As it's putting it to the screen, it's also putting it to the file. You can key the output as well so that you can watch the screen and have it go into the file at the same time. Now the -OA option is writing 3 files at once, so you couldn't really key all 3 of them at the same time, but you could at least watch it. The other option you could do is you could have Wireshark or TCP dump running over in one window like this, and then clear those out. So if we ran that over here, and then we did a scan in the other window. Now, at first, when we very first started the scan, you could see these arcs fire off in the background, but you'll notice that the actual ACK scan hasn't started yet. We'll be able to watch that over in this window as it occurs. Of course, it'd be, if you're doing a full network scan, it's not going to make any sense over in the TCP dump window because it's going to be flying by. But it is useful to at least make sure that something's going on in the background. The other thing you can do is, if you recall earlier, Adrian had hit V while he was running the scan, and that increased the verbosity. So if you're not seeing the output that you wanted to see, you could just keep hitting V and increase the verbosity. Another thing you can do is there's a debug level built in, and the letter D for debug works the same way as the V. If you hit D, it increases the debug level while the scan's running. And you can increase that and actually get more information. Later, when Martin does the scripting, the D option would be more applicable to that because when the scripts output, they're outputting a lot of times to the debug. They'll output to the verbose section as well, but it's usually not nearly as much information as the debug information. Is the student network working okay?
Mainly working okay.
I can try it.
I'm gonna try Backbone, but I'm working on making it work okay.
Okay. I'm going to join the infected network. No, not really. Let's see. Okay, well, it looks like I'm joined to that network at the moment, so
You can give it a shot.
Yeah,
If
give
you
it a try.
catch your Backbone, it might probably be more reliable. The idea was that we have two different subnets, and you can see more of the things that happen when you're actually not scanning something in the local area network, but that might be failing, so
okay,
I'm working on it, but yeah, stay on Backbone properly.
okay. Let me give this one a try. I just need something that takes long enough to scan that I can actually hit the V and the D options. So, okay, so I started to scan on the Class C subnet, and if I hit the V, it's going to increase the verbosity, and you can see that I'm actually getting a little more information, but it's pretty limited with the verbosity options. And then if I use the debugging level, when you get to, I think it's about 2 or 3, you start to see a little more information at about debug level 3. And you can really tell that there's some stuff going on in the background. Sometimes I do this every once in a while. I'll just turn around to my scanner and ramp up D to 3 or 4 and just make sure the thing's still alive, you know, because it's been sitting there for 5 hours. And then come back and dial the D back down, because you don't want the computer to be spinning its wheels trying to draw stuff on the
So how do
screen.
you dial it back down?
Oh, Shift D. So, oops, it finished on me. Let me try it again. Everything's working great right now, Adrian. Good job, man. It's too fast. So, all right, let me try it again. So it's at level D3. Okay, and then I hit Shift D again and dropped it back down real fast. So actually now things working great. And then Shift V does the same thing. And you can set those options as well when we were doing the scan. So the number of V's is roughly equal to the number of verbosity levels, and the same thing for the number of D's. So that put me into level 3 right away, and then I can dial it back down. Does that answer your question?
Yep.
Okay. So any questions on how to see what's going on? All right, so by default, you're going to use the SynScan, assuming you're using Poly, because you're going to be running as root by default. And then you'll do the Connect scan if you're not running as root. If you want to avoid the Connect scan if you're trying not to type a bunch of resources, but if you hit the -SV option, remember you're automatically going to have to do a Connect scan even if you hit the SS option, because you can't do version scanning. We'll see why here in a minute without that. Don't forget your UDP scans, and if you want to try the ACK scan, of all the alternate scanning types, I found the ACK is kind of useful. It works, it detects if the firewall is stateful or not. So if you had a port that you already knew was open because you had already scanned, then you could follow up with the ACK scan and compare the results to the initial scan on the ports that you knew were open. And if the ACK doesn't show that it's unfiltered, then somewhere along that trace route, there must have been a stateful firewall or something similar that dropped the packet. So you can start to combine these scans together to get a picture of what's going on with the network. Now, it does have a trace route option built right into it, so you don't necessarily have to do it that way. So, Adrian, is there a particular machine?
Try 10003.
3? Okay, cool, thanks. I'll just try this one.
I think I finally got it working, though. How long, I don't know.
Let's see. Let's try.
That is our test network. No, that's not currently networked. Working on that.
We can try a discovery scan we learned about earlier and see if we can find a host that's up. If not, we'll switch back to the host-only network. Okay, there's one at 129 and 138, so that's enough information. Now the TCP dump's not working, or it's not capturing traffic anymore, because remember I set it to that Ethernet interface, and I also filtered on those host names, and we're not meeting any of that criteria when we switched over to the 10 dot network. Okay. So it was one hop, and not very interesting because I'm on the same subnet, so one hop away. But there is a trace route built in that we could have used as well to possibly.
Student may work now, actually.
Oh, okay, cool. If there was firewalls in the way, we may have been able to figure out what they were. Also, border routers and things like that can be set to drop unsolicited acts if they have the ability to do stateful inspection. All right, so let's go back and look at a full Metasploitable scan. Actually, let me drop off the network. Okay, so we'll go back to the local, well, the host-only network, I should say. Okay, let's do an Nmap on the Metasploitable machine, which I believe is at 101. Will be real obvious here in a minute.
You might want to blow up your terminal size. Thanks.
Okay, so in the column here, it's showing what the service is, at least based on what the port number is. And when you do the default, these are generally very accurate, especially in the more popular services. But if you run into some services that are running on unusual ports, like the administrator has switched the ports around instead of running FTP on 21, maybe they like to run it on 2121 or something like that. The names of the service in this column over here are not necessarily going to match up to what's really running on that port. It may help for a second to talk about what a service is. So when a program wants to have network connectivity, they typically will open a socket and they'll be assigned a port by the operating system, typically the port of their choice. They can pick whatever they want. The only exception would be if some other process had just grabbed that port already. They can't share. Their ports are exclusive. So when we say services, we're simply just talking about some program that got assigned some port by the operating system, and now it can talk on the network through that socket that's connected to that port. So there are, of course, special services like web services that talk certain protocols. So I'll try not to mix those together too much. But the version of software running here is stated as FTP. Well, why is that? Well, if we go into the user and share Nmap, and you look inside that directory, you'll see that there's several files in there by default. And one of them is the services file. So we can take a look at that file. I guess I should probably do less, since it's a pretty good sized file. So in that file is the services that are going to be listed in that service column by default. So for example, let's go down to 21. So if we happen to find 21 on TCP, then what's going to be printed in that service column is whatever description is over here on the left inside of this file. And of course, in this case, it's FTP. And that's why you kind of get that generic listing of what's running on there, which may vary wildly from what actually lists when you do the service version detection. So some of the other common ones would be SSH, and we'll go down and look at the HTTP. Okay. And you notice that there's numbers associated with the protocol running on that port. When they went out on the internet and they did a study of which services were running on which ports most of the time, they then ranked the services in this file using what effectively, this is like a percentage, if you will. So this service, web, it looks like in the file that I have anyway, must have shown up roughly about 48% of the time. I think is the way that you would interpret that. Does anybody have a confirmation on that that's the best way to interpret that? Not really? Okay, I think it's percentage. I think it's the percentage of what they saw. Because if you add up the numbers in this file, unless it's a weird coincidence, they roughly add up to about 1. So it does seem to be out of 100%. So obviously the web is by far the most common protocol. Now this ranking gets to be, oh yes?
In the description up at the top, it says that that particular one is for the open frequency.
So open port frequency, okay. Yeah. So it's the open port would be the percentage that they actually found something running on that particular port. So percentage of the time that they figured out something was running on that port. So thanks for the clarification. So back to the FTP that we were looking at earlier. We saw that was the description. Okay, so if we look back over at our scan results. Running the scan again to get a listing. So one of the ones that we might look at would be this one on 3306, the MySQL service. And it could very well be a MySQL service. It's just that now you know how these names get into the service column. You know, it may or may not necessarily be quite that service running on that port unless the most common program found open on that port is actually what's running. Okay, so let's take a look at doing some comparisons between the service version scanning and the default scanning. So if you're following along, these are this is what you want to use: the plain Nmap scan, and then for the same machine, use the -SV option. And try to run them one after another and then compare the two listings. So I'm going to go back over here and we'll do that in the demo. So we already did this one here, and we can scroll up. Even though we've cleared the screen, we can still scroll up and see what those results were. So I'm going to go ahead and do the version. And I'm going to go ahead and restrict it just for the sake of time to that one port, because it would take a while to fingerprint every single one of the services running in Metasploitable. There's over 20, and of course, as you noticed, it's designed to be vulnerable, so there's going to be a lot of services running on that. Okay, so in this case, the version that came back, it was still the same service version. It was MySQL, but it was able to figure out what, appropriately enough, version of MySQL was running and print that out to the screen. And it actually figured out quite a bit from the headers that it got back. We can also do this on the FTP one that we looked at earlier. If y'all are trying this on the student network, you may want to pick a port that you found earlier and stick with that one as well. It'll run quite a bit faster for you. Okay, so in the service column, we still have that it's FTP, but over in the version column, we can see it's actually the VS FTP daemon, and it's version 234. So now you can start to see the connection between doing the service version scanning and moving on to the next phase in the assessment, which would be trying to figure out if the versions of the services that you're finding might possibly match a version that would have some sort of vulnerability that you would know about. So for example, if you were to do a Nessus scan on this port as a follow-up, it may already know that version 234 has some concerns with it that someone might be able to take advantage of. So after lunch, we'll take a look and see how this mechanism actually works. How is Nmap figuring out what versions are running on here? And there's going to be another file. We're going to take a look at the service versions file. It's got these probes in it. So if you want to take a look at that during the break, that's what we'll be heading next. And Darren, is now a good time to break for lunch?
Yes, sir.
Okay. All right. We'll do that now then. Thanks.
Okay. I just tried to make 10007 look like a Novell NetWell box. It's actually Windows 7.
10007?
Yeah, I don't know if it's going to work. Well, we'll find out. I haven't updated that program in a while.
Okay. Oh, I got to get back on the network to test that for you.
I'll go